This one. Great. All right. So now every single voice and noise is being recorded, and hopefully she can see the board. All right. So we're gonna do two different intervals. The first one will be proportions of blue. So we'll do that one first. How do I do it? Or how do you do it? I mean, it's your test. So check the conditions. What conditions do you need to check?
Simple random sample.
Simple random sample. Was it random?
Yeah.
Yeah. I mean, we're assuming it's a random bag. You picked off the thing. We're going to get everything in the box. So what's random sample? Awesome. What's next? So you're checking random sample, and then you're also checking if it's 10 times the sample is less than the population. Is that true?
Probably yes.
How many Sour Patch Kids are made? A lot. And the third one is?
The N is greater than or equal to 3.
For proportions, NP.
Good.
And then NQ for the equal to 10. So, checking that, what is the proportion of success of blues? We had 30 blues and we had 159 in our sample. So what's the proportion of success? And then multiply that by the number of our sample size. I know. I know. The goal is this is recorded, so then I can upload it to either YouTube or I can upload it to
you can't see that.
Oh.
That's what I was trying to say.
Then I'll move it up so that she can see that. That was way too far up. There we go. So, random sample, the population, the NP, and the NQ in the upper right-hand corner.
Okay.
Very helpful. So, did that pass? What's the proportion of success? Because we need to know that.
30 out of 1.
What is it?
18.8.
18.8?
Point for 9. 8.
Okay, 0.18. Okay. So this would be 159 times 0.18. That's obviously greater than 10. And so if I do the 82%, then that's going to be also bigger. So that's great. That's checked. So now I can do a confidence interval. So what goes first in my confidence interval formula?
Your average. Or your proportion.
Proportion. So p hat, which is what?
0.18.
0.18. Then what comes next?
Plus or minus.
Plus or minus. Then we
Z-score.
the z-score. And how confident do we want to be?
95.
95? Okay, we're going to do 95% confidence. So what is the z-score for 95% confidence?
Using how many degrees?
Well, do I care about degrees of freedom?
It's a z-score.
It's a z-score. I don't care about degrees of freedom. Okay, so z-scores are the infinity of the term.
It is
90%.
1.96.
Oh, 95, yeah. So 1.96. What goes into parentheses?
Your
And for the standard deviation, this formula for this one is what?
0.18 times 0.8 p times q over n. Oh, it's square root of all.
Yeah.
Over 159.
So standard deviation of my proportion will be p hat times q hat over n, the sample size, which is these numbers. Plug them into your calculator. So what interval do we get?
I'll do it really quick.
Go for it.
I got 0.120 and then 0.23, well, 0.240.
Anybody else agree? Yeah. Emily agrees. All right. Okay, so you're just not gonna okay. Have 2 to 3 decimal places, that's good. Alright, so how do I interpret this interval?
We are 95% certain that the true mean is in between the 1.20.
The true proportion of blue, we did Sour Patch Kids, so this is proportion of blue Sour
Sour
Patch
Patch Kids is in between, but for the interval that,
Kids.
It's
That,
both
put the
point-
two numbers, How would I do just the level? How would I only interpret the 95% part? What is only 95 part?
95% of our samples will have the true proportion of blue
Not 95% of our samples, 95% of our
intervals.
intervals. So if I use the same method with different samples each time, 95% of those intervals in the long run or eventually will have the true proportion.
Chart, like, around the line.
Yep, and the ones that are on the outside. Yep.
will you leave this up for the test?
No. Alright, so proportion, now confidence interval for the average height. So instead of being proportions and categorical, it's now what?
Quantitative.
Quantitative and
T.
why is it T?
Because it's not,
You go.
it's not proportion.
It could be Z though.
Because
Oh,
we
that's
know
deviation,
this.
yeah.
We don't know the population.
Oh, we don't
standard
do
deviation.
this, yeah.
Yeah, we don't know
Okay.
the population.
So if I know the population standard deviation of all of the heights of our Sour Patch, then I would use sigma. But I don't, so I'm gonna use S. So what are my conditions I need to check?
Random sample.
Okay.
The thing. Yeah, that's what I'm gonna guess.
Then just hit
N is bigger than
30.
Perfect. And equal to, right? If N was less than 30, in this case it's not, but if N was less than 30, what would we need to make?
You need to do something.
That's gonna be.
Bystander. Is this thing?
Box
Box plot.
Box plot. Okay, so if you make a box plot, can I assume this is approximately normal?
Probably.
Yeah. What if I did that one?
No, that's not normal.
No, because it's skewed to the left or to the right. So
Right.
right, wherever your weirdness is, that's where it's skewed. Okay. So we have those 3 conditions. They obviously met them. So what would my interval formula look like?
The X bar
X
Average.
bar.
plus or minus the
T
interval.
value.
Be T in this case. How confident do I want to be?
90%.
95, right? And then standard deviation is what?
And that's the S.
It is S.
Square root of.
Oh, that's square root of N.
Yeah.
Huh?
That's what I said.
So we don't know standard deviation. If you want, I don't like to figure out the average. So there's, that's a good question. Whoever finds it first can tell us the answer. But I'm gonna put it on my list and then we'll figure it out. Well,
Wait, so that's 43 2.54.
there are 43 of those, yes.
So I just put all those in.
There's a total of 130.
One
you counted
stat
for height.
statistic or the one variable stat.
Well then my average is funky. There's only 130 point heights.
Yeah.
Okay, well then let's just make up a standard deviation. What's a good standard deviation you want to make up?
You know, like
4.
0.4? Okay. We're gonna say our sample standard deviation is 0.4.
okay.
Since we're obviously wonky with our height data. Oh, because I forgot Blake's. Right. Oh well. We'll just use this.
She didn't count yours.
I even kept it because it's over there.
She doesn't matter about you.
Oh well, we already did proportions, so
Good
we're
job. Ouch. Good
He's
job.
still got to eat Sour Patch. Oh.
Dang, it's bad, man. You should have given me. No.
Not worthy. Ooh.
So do your means. Make your interval.
How do you find T?
I don't know. How do you
Are we doing the infinite thing?
Are we doing-
one?
So 159 still, so our number.
Yeah, so our sample has 159, so degrees of freedom, which is n minus 1, will give you 158. So you can either do this exact thing in your calculator, if you want to practice that, you can, or you can do this estimating on your formula sheet. So if you estimate on your formula sheet, it would be round it down to 100 because that's the closest. So on the sheet, round to 100. If you use your calculator, then you need to do second bars. You do the T, the inverse T, and we want 95 in the middle. Then we have 5% left over, so this would be 0 to 5. So the left area is going to be 0.975, and degrees of freedom is 158. I think that's the information it wants.
So area says 0.975.
Wait, why the
Yeah.
T interval?
Just the T,
The N,
there's just a T number.
the
Oh.
NT,
Area would be 0.975, degrees of freedom is 158.
what?
What are you trying to do? I'm doing inverse T.
Oh, I put the numbers in backwards. So the area is 158,
No, the area is 95 plus 0 to 5.
25.025.
Mhm.
I paste it, and then it says error.
Mine doesn't.
Mine
To do
does.
0.975. Okay. So if you use your calculator, your T value would be 1.975. If you used your sheet at 100, it should be 1.94. I will take either of those T scores. You can use your calculator and be more exact, or you can use your sheet.
1.975.
Yeah, that's what your calculator gave you, this is what your sheet gave you. And remember from the free response quiz, there were like 5 different answers that were possible. And this is why.
Okay. So that's for our T, right?
That's your T.
And
Standard
then,
deviation, we're just assuming is 0.4. If we move that up, we'll see how accurate it ends up
and
being.
then X bar is the 2.19.
So make sure when you're showing work, your conditions are checked, and you show it, they're checked which interval type you're using. So when you're using an X bar or a P hat, a T or a Z, numbers plug into your interval formula so I can see what work you did, and then your interval actual answer. So what did you get?
2.127, 2.253.
That's easy.
I got 2.1273.
That's using the chart. Okay. So what did you get, Alex?
2.1273 and then 2.2527.
Oh.
I'm
I
not
Did you
sure.
use the chart or did you use the calculator?
The calculator.
Oh, okay. So
That is
makes sense.
not what I got.
No, that's the exact sheet.
That is not what I got.
So what did
I got-
you get?
I got 183, like 2.183,
2.1.
and then 2.196.
How's mine not right?
Did you use the calculator or the sheet?
You did the same thing I did.
Okay, so you're both the same one. So you're both calculator. This is the sheet.
No, that's calculated.
Oh. Okay.
Okay, did you got the calculator number, right? The,
You use 1.975, so then you
Yeah.
have 2. Okay. 1.975.
Let me see your
per second.
Why did you wrong?
Alex, I didn't want to write down all the decimals.
There's only 4.
Okay.
Equals, and then I want 2.19 over there. I want second so short alpha A. So then I want 2.19 plus alpha A minus alpha A.
You use the sheet you got.
I agree with this one for the calculator number.
Well, that's just the one that I did when I.
That's what I
did the
got
T
using
interval.
1.975.
That's what I use.
That's what I overprinted, so.
But you got, did you get the 2.183?
Yeah. No, I got the 2.12.
Oh,
Yeah.
right, so,
What are we talking?
oh, that's 0.4, not 0.04.
Oh, okay. There you go.
Yeah, standard deviation is different. So obviously, if your standard deviation gets smaller, what does your interval get? Larger. Yeah, because that's a smaller. Wait. Yeah, because I thought. Oh, that's
It gets
smaller. No, that's
smaller.
smaller. That's a smaller fraction. So that's a smaller interval. Did anyone use the sheet or anyone use the calculator number? I used the sheet, but I got the same thing. Okay.
Why did we find
See how
the
rounding doesn't matter?
calculator number?
Because you need something to plug into the thingy.
Yeah.
No.
If you use the
to your
interval test,
formula.
yes, to show that work of what you're plugging in.
Oh, I just went to T interval and it
Yeah, but
said
like on
X
paper.
bar,
Okay, but you still need to write
S,
something on your paper.
Yes, I still need to see your numbers plugged in.
So if we write down the paper number, but we just plug it into our calculator, it's not still like the.
That's fine.
But why wouldn't you just put 9.95? Oh, 0.975.
Yeah, because it's 0.95 plus this tail. The area is the whole left side.
That's 0.975, right? Then it's not what we got for the calculator.
Yeah, it is.
No. Then it's 2.1182 and then 2.2618. We just put.
This number, the 1.975, came from putting in an area of 0.975. It just happens to match the 975. That was not planned. That just happens to be it. So when you did left area, did you put 0.975?
Yes.
DF of 158.
Yes.
Do it again. So your left area is 0.975, and your DF is 158.
Oh, 1.97.
That's where I got that number, and that's the number I plugged in. That one. Because you need the T value.
That you just need that to write on your paper to say you found the T in it.
Yeah.
That's all it's there for.
Yeah, but
It's just to show me what number you're using and communicate to me your thinking. Statistics is about communication. If you can't communicate, why are you even trying to write something down for someone else?
it doesn't even ask for that. You just put 0.95.
I know that. Yes.
So why would you need to do that?
To show me what you know you're doing. If you just know how to use a calculator, great. The AP stat test is written so they know you know how to use a calculator. They will ask you questions that make you think. They are really good about that. If you don't know what you're doing, then you're a squat on the test. That's totally mathematical. Squat. Okay. Questions about confidence intervals for proportions or for averages? There is no paired on the test.
Because that was
Okay. Questions about intervals, interpretation, or level interpretation. Level, make sure you say in the long run or eventually. 95% of all the intervals that I make will actually contain the true value. The user saying the true value is about, or 95% confidential. Is it proportion? Yes, make sure it's the true, whether that's true proportion or true average. Make sure it has context so I know what your proportion or average is for. Other questions? What's a point estimate? P hat. What's the population characteristic the point estimate is for? P. So P hat goes for P. What's X bar go to? Mu.
Is there gonna be any of like all three on the back sheet are basically what the test is over?
Yeah.
So is there gonna be like a part where we have to like prove our checks? You know what I'm saying?
I mean, for like this part, we can concede that. That's obvious. But like if it's an NP or NQ, or
Like, do we have to work that out?
yeah, or at least put the two numbers that you're multiplying, and then put a check mark. That way, I know you're plugging the right numbers in.
Okay.
Yeah. All right. And I'll pass out the tips. Stop sharing.